Moving into Module 4, Lesson 9, we're going to start looking at different types of curves and this thing called data distributions. And mostly we're really trying to identify these things called normal distributions, because with normal distributions, we can make a lot of decisions based on smaller samples of similar types of surveys. And based on those, we can actually go through and again, make some predictions and be able to do that. So the normal distribution is really going to be critical when we're looking at a lot of different types of data. So we are given a bunch of heights of fossils of remains of compies that were found. And the data that was given to us was that at a height of 26 for the fossil that we found one compy. 27 height, we found 5, 28, 12, 29, 22, 30, 40, 31, 60, 32, 90, and so on. This last piece right here is what is known as the relative frequency. We calculate that by dividing 1 by the total number of compies or fossils that we found, which is 660. So that would be 1 divided by 660, 5 divided by 660, 100 divided by 660, 90 divided by 660, and so on. That gives us our relative frequency. So that's the data that we are given. So based on that data, we plot the points. Notice here is our heights down here. So our heights are 26, 28, 30. Of course, 31 is here, 33 is here, 35 is here, and so on. And we have our relative frequencies over here, which was the calculated values. And so these represent our percentages. So what that says is about, because notice this is a little bit above 0.15. So about 15% of the compies or fossils that were found were at a height of 33, and 15% were at a height of 34. So we can see about 30% there were at a height of 33 to 40 to 34. So we can see that those particular numbers as we're looking at the data and seeing what's happening. This looks like a pretty good symmetrical distribution. Normal distributions have to be symmetrical. And what we're going to do now is we're going to draw some stuff. So what we want to do is we want to figure out the average. So here is our data. To figure out the average, we would, of course, add all these up and add all these up and divide by 2, or really we'd be taking an average of all of them. So we'd add up all the data points. This is just the data that's here. We'd have to add up all of our heights that we are given, and we would divide by the total number of heights, okay? And notice that we have 660 heights, so we would be adding up not just these numbers and dividing by 660, we'd add up all the values that we actually found and dividing by 660. That would give us our average. And in the problem, they tell us that the average is, so notice here, the mean is 33.5. So we go over here, we know that our mean is located at 33.5, which is right here. So that would be our X bar. And we know from the same thing down here in one of the problems, we know that one of our other data values is 2.56. So that's our standard deviation. So it's about 2.5. So that means from this point, we're going to go over 2.5. So that would be 1/2. 1 and 2, so we'd go right there. So one of our standard deviations would be approximately there. That would be one of our standard deviations. Remember, that's the distance of the standard deviation between the mean and the first standard deviation. If I go 2.5 this way, that would be 1, 2.5, so it would be this line right here. That would be my negative standard deviation. So notice that my standard deviation, we go 2.5 to the right, 2.5 to the left, and that's one standard deviation away. So the majority of the values would be packed inside of those numbers, and we can see based on the graph that that's true. If I were to go 2 standard deviations, I'd go another 2.5. So 1, 2.5. My half would end up right here, which would be at this point right here. So that would be 2 standard deviations away. If I go over this way, 1, 2.5, I would end up down here, well, at this point right here. and that would be my other one. So that would be -2 standard deviations away. And then I can go another 2.5. So 1, 2.5. I go all the way out here. So that would be 3 standard deviations away. And if I go another 2.5 in the other direction, I'm going to go right to this point. You can't see it based on that, I don't think. But I can see it right there. So that would be my -3. So whenever we're dealing with standard deviations, we always go up to 3. And what we say with 3 standard deviations is about 99.9% of my data is going to be inside of there. And then at 2 standard deviations away, which are these two numbers here, we are around 95%. Sometimes it could be 97%. We go over between these two, and it could be anywhere from 80 to 90% in that particular range of values. So that's what we're looking at when we have all of those. So what does it mean? What does the relative frequency of 0.136 mean for a height of 32? That means 13.6% of the compies, of the dinos, I'm going to put dinos, are 32 centimeters high. Okay, not height, but high. Okay, so that's what we have for that particular value. What is the width of each bar? So we notice here that the width of each bar, so of course if this is 31, we know each bar has to be 1 centimeter. What is the area? So the area would be the length times the width. That's what we normally do, right? And so the width of each bar is 1 centimeter, so we know that one's 1. And for 32 centimeters, the height of that bar is 0.136. So we multiply those together, we get 0.136, okay? And then the mean of the distribution, so we've already done those two. Approximate the value. So of course, notice here we do 33.5 minus 2, and I estimated this to 2.5 approximately. So I said, well, that's about, if we notice that the first standard deviation is located here at 31, the second standard and the first standard deviation on the other side is located at 36. So that's what we have for our values there. Draw a smooth curve. So this is the last piece. So what we want to do is we want to draw a smooth curve, and this is what is known as our normal distribution. If it is a normal distribution, we draw it always through the centers. So I'm going to mark all the centers of all of them, and I have to go through that point every time. Okay, so not around it, not close to it, but through it. So notice here I'm going to go up, up, up. I'm going to hit this one, and then I'm going to start turning around. I'm going to go up a little bit because I need to, and then I'm going to start going down, and always through that center point. And that way then I can hit the center point every single time. And this is what is known as a bell curve. If it looks like a good bell curve, meaning it's even on both sides, then it is what is known as a normal distribution. So this one is definitely a normal distribution. And then we'll go through the second example next.